Hi everyone, in this video I'm going to give you the double angle properties and show you how we're going to use it in regards to solving equations. So there are 5 double angle properties, 3 for cosine, and the ones for cosine are just that you could rewrite them in different ways. So I'm going to list them now and then I'm going to show you how we can use it. Okay, so these again, you want to add these to your notes. They're the double angle properties. Okay, so what it says is that sine of 2a, so that's sine of double a, which is why it's called the double angle property, equals 2 sine a cosine a. And we're not going to prove why this is true. There is a nice proof for it if you know the composite argument property or the sum property. But this year we're not going to do that. I'm just showing you what they are and how to use them. So that's the sine one. Then you have cosine of 2a equals cosine squared of a minus sine squared of a. And as you know, you can substitute in for cosine squared as 1 minus sine squared. And if you do that, you get this other double angle property, which is 1 minus 2 sine squared a. Or you could substitute in for sine squared as 1 minus cosine squared. And if you do that and simplify, you get that cosine of 2a could also equal 2 cosine squared a minus 1. So that's why I said there are 3 different ways to write the cosine one. Then you also have tangent. Tangent of 2a equals 2 tangent of a, all divided by 1 minus 2 tan squared a. Alright, so you're going to want these in your notes, and I'm going to show you how we use them in terms of solving equations. There are other problems that these are useful for, but we're just going to focus on solving. So they could have been used for verifying identities, what we did before solving, and then also like other types of kind of like unit circle problems. All right, so I am going to do one example on the next slide. So here's the example. We are trying to solve for the general solutions of sine of 2x minus sine of x equals 0. So as it is, just looking at it, I can't really do anything with this. Because the first term is sine of 2x, I can't like factor anything out. And there's not really anything else I could do because they don't have the same argument. So to fix that, I'm going to change the sign of 2x using my double angle to 2 sine x cosine x. And then I still have this minus sine x. So all I did was I changed the sign of 2x using my double angle property into 2 sine x cosine x. And then the other sine x just stays the same. Now I have something that I could factor. I see that both terms have sine of x, so I could factor that out as the GCF. And then what I'm left with is 2 cosine x minus 1. Now I could use my zero product property, so I have sine of x equals 0 and 2 cosine x minus 1 equals 0. The one on my left is already by itself. The sine is by itself, so I could take the arc sine of both sides. And what I'll get here is x equals the sine inverse of 0 plus, we'll just do this in degrees, 360 degrees n, or x equals 180 minus sine inverse of 0 plus 360 degrees n. So what do I have here? Let's see. X equals the sine inverse of 0, that's the y coordinate, of 0, that's going to happen at 0. So I get 0 plus 360 degrees n, which is just 360 degrees n. Okay, then when I do 180 minus 0, I'm going to get 180. So my other expression here is 180 plus 360 degrees n. Okay, my other equation here, I do have to get the cosine by itself, so I'm going to add 1, divide by 2, and that gets me cosine of x equals 1/2. Then I take the arc cosine of both sides. And I'm left with x equals plus or minus the inverse cosine of 1/2 plus 360 degrees n, which means x equals plus or minus 60 degrees plus 360 degrees n. So I have my 4 solutions. My x equals 360 degrees n, my x equals 180 plus 360 degrees n, and my x equals plus or minus 60 plus 360 degrees n. Alright, notice that I could not have solved this, though, if I did not make this substitution in the beginning. So when I need to use a double angle property to solve, it's going to be that I have to make this type of substitution in order to like factor or get it to be the same type of argument, right? So here we had 2x and x, and we couldn't really do anything with that, but now everything had an argument of x. What I was taking the trig function of was just x. So that's going to be like the main way that we use them for equations, by using substitution into what would have been a double angle into what it equals. It could also go the other way, but it's just more common when solving that it's going to be given to us as a double angle, and then we have to change it. When it comes to cosine, you're going to make the best substitution. So sometimes you're going to want to make the substitution just have cosine, sometimes just have sine. If it doesn't matter, then that's when you'll use the cosine squared minus the sine squared. And yeah, that's how you use it. So now you're going to do a couple problems as practice on how to use this. And thanks for watching.